Okay, we got part three now of some ratios and proportions, and this one is going to really focus on solving proportions using the cross product technique. So let's take a look at how to solve for some proportions. Okay, so here we go. This is a proportion, and notice we have to solve for x in here. X is missing variable. So the technique we're about to use is called the cross product technique. So we are just going to cross multiply in here. So x times 6 is 6x. And then we're going to set that equal to 3 times 14. Well, 3 times 14 is 42. So we're almost done in here. We're just going to divide both sides by 6. And notice we got 7. So 7 is this missing number right there. And notice you can also pick up, ooh, Mr. Keys, I saw a different way. I saw a scale factor, 7 to 14, 3 to 6. Yeah, that's one way to do it if the numbers are real easy. Sometimes if they're decimals, it's not going to be so intuitive what the scale factor is. But in this case, yes, 7 to 14, 3 to 6 right there. And the answer is 7. Let's take a look at this one in here. Again, we're just going to use the same exact technique, the cross product technique. 5 times y is 5y. And 13 times 15, oh boy, 13 times 15, that is 195. So we divide both sides by 5, and we get 39. So that's the answer to this one in here. So this would be 39. And if you're noticing, Mr. Keys, I noticed that was a scale factor of 3, and now it's a scale factor of 3. Yeah, you're right. That might have been a faster way to do it instead of doing this cross product technique. But not it's not always we see a nice whole number for a scale factor. Make sure you really understand how to use a cross product technique, because this next one is not such a clear thing. Hey, what's the scale factor here between 6 and 5? It's not a whole number. So we're just going to cross multiply and use this technique. So I got 6 times w equals 35. I'm going to divide both sides by 6. W turns out to be not a whole number. 35 divided by 6, you could write it 35 divided by 6, or the decimal equivalent is 5.83, and the 3 is repeated. Okay, so those are 3 quick examples of how to solve for proportions when we have a missing variable. All right, here's another example on here, and this one is in the context of a word problem. What is the word problem? Well, let's say you scored 1200 on your SAT score. Notice the possible perfect score in an SAT score is 1600. So you got 1200 out of 1600. That feels like a ratio. It feels like a comparison of two numbers. You scored 1200 out of 1600. Well, now we're trying to answer the question, what would I expect to score on the ACT test, since that one has a perfect score out of 36. So think of this phrase here, ACT score, as the missing variable. You can call it one variable if you want, S or X or whatever you want. But that's what we're going to try to find. What is our predicted score here of SAT score if I did this well on an SAT? So I'm going to cross multiply in here. And by the way, let's just call this X for now. Right? This whole score for an ACT, let's call that X. So I got 1200 times 36. That's a big number. That's 43,200. And then over here, I have 1600 times X. And we're so close to being done. We're just going to divide both sides by 1600. And X is going to be what number? Well, I'm going to take 43,200 divided by 1600, and I got 27. So if all these tests were kind of fair, meaning if you got one type of percent on one and it should be the same percent on the other, basically we're estimating here, hey, if you got a 1200 out of 1600 on your SAT, what should I expect if I'm taking the ACT? Well, you should expect somewhere around a 27 if these two were equal. All right, so that's just one type of problem where we have context. Another technique in here to solve for proportions is Well, it's the same exact technique, but notice we have an extra little wrinkle in all these problems here. All three of these problems have been done. Make sure you pause and check them out. The wrinkle is essentially we have a binomial, we have an expression in the numerator here where we have to use the distributive property to, when we cross multiply, 20 times x is 20x, 2 times 20 is 40 here. Same with the next one here. Notice this expression here, when we times it by 4, we're going to be using the distributive property. Notice in this last example, we used the distributive property one more time. Notice 4 is being multiplied this whole thing. That's what we get over here. And 5 is being multiplied to that expression. That's how we're getting these numbers over here. So this is a little bit more intense. Make sure you're very comfortable with cross multiplying. It is the same technique, but using the distributive property to solve for all these. Hey, keep in mind, not everything's a nice number. Make sure you're very comfortable with solving these equations. It's actually more algebra than anything else. All right, we'll see the applications of this algebra as we go through the rest of chapter 7. Let me do one more for this video in here to kind of show you how to use this distributive property. I'm going to pick the hardest one. I'm going to pick this one right here. Let me make this a little bit bigger, slide it over. So here we go. I'm going to go 7 times z plus 4, which is 7z plus 28. And then I'm going to go 9 times z minus 1. So that's going to be 9z minus 9. So when I'm looking at this, I got z's on both sides. I'm going to arbitrarily move the z's onto the right-hand side. So I got to subtract 7. I'm left with 2z. And then if I'm collecting all the z's on the right, I am going to collect the numbers onto the left. So 28 and 9 looks like it's 37. So I divide both sides by 2. Z turns out to be 37 over 2. That looks like 18 and a half. All right, so that's how you do that one right there.